Okay, our last example that we'll look at as far as showing that lines are parallel, we're going to do a proof of the alternate exterior angles theorem, the one that we have not looked at yet. For this version, we are going to try and only use the alternate interior angles theorem. So again, when we are trying to show that lines are parallel, and we can only use this theorem, at the very end of my proof, I want to be able to say something like 4 and 6 are congruent, or 3 and 5 are congruent, because those are my alternate interior angle pairs. And if those types of angles are the same, then I know that the lines have to be parallel. So we're doing this in reverse order of how we started this whole proof process. So what I do know, I'm just going to draw a little bit on my picture. I know that they tell me at the very beginning that 2 and 8 are the same. So I have a connection there. They are exactly the same. So you need to think a little bit about how 2 and 8 are related to our alternate interior angles. And there's a couple ways to do this, but I do think one way is much easier than the other. And to me, I see a natural connection between 4 and 2, okay, because they're vertical angles. And I see another connection between 6 and 8. They're also vertical angles. So there's a way to, in this picture, to say, well, I know that 6 and 8 are the same because of vertical angles. I know that 8 and 2 are the same because they told me that at the very beginning. That's what we're assuming. And I know that 2 and 4 are the same. And so if I kind of go a roundabout way, I can say 6 and 4 are the same. And because 6 and 4 are alternate interior angles, and if they are the same, that implies the lines are parallel. That's kind of the setup for this particular proof. Okay, so what I'm going to do is just walk through the proof again. So we're going to say that angle 2 is congruent to angle 8 because that was the given. And you could do this in one step if you wanted to, probably just for the reasoning part of it. I'm going to write it out separately, but we said that angle 4 is congruent to angle 2 because of vertical angles. Okay, we said that angle 6 was congruent to angle 8, also because of vertical angles. So again, kind of like I think a previous example at some point, I'm fine if you were to put angle 6 is congruent to angle 8 right there, and just kind of skip line 3 and kind of combine these two steps just into one line. That's totally fine, but just so I have a little bit more space, I'm going to do it this way. Okay, so we have all this written down. One of them is just because they told us that. They told us alternate exterior angles have to be the same, so assume that. But now we have a chain reaction. If we kind of look through this, 6, let's see if I can highlight some things here. Okay, 6 goes to 8, 8 goes to 2, and 2 leads us to 4. So in the end, what that tells me is that angle 4 has to be the same as angle 6. Okay, so I think looking at the picture is a little bit easier for that, right? Okay, you can say, hey, we went from 6 to 8, 8 to 2, 2 to 4, therefore 4 and 6 are the same. The reason why, when we have all these congruent angles and we're trying to do a shortcut, that's the transitive property. Okay, and our goal, again, for these is to show that L is parallel to M. And now we can, because we've shown that there's a pair of alternate interior angles that have to be the same. And this theorem, read kind of in reverse, tells us that. So again, we know this, that will tell us this because of this. These proofs end just a little different than what we're used to. That's kind of the thought process behind it. Stop there.